We're going to be looking at how discrete and continuous functions appear differently in different forms. You may remember the previous video I gave an example about buying video games, and in that I had said discrete functions have to be whole numbers on their input. So in this case, we have an input of 1, we get an output of 2. We have an input of 2, we get an output of 3. These are the inputs, or also known as the domain values. And then we get our f of n, also known as the output, or the range values. On a continuous function, we're not limited to whole number increments. There's no difference. We still have the input, or the domain value, and we have our output, or the range value. But notice, we can have decimals on a continuous function. Okay, we're going to move on and look at their graphs. The key is that discrete graphs are separate individual points. Maybe this could be you're stacking books, or you are trying on different shirts. The key is it's not a gradual thing. It either is or isn't. So you've either moved one book or you've moved 2 books. You don't move part of a book. Or you either have tried on a shirt or you haven't. You haven't halfway tried on a shirt. For continuous graphs, that is where we can have a straight line. So maybe that is the amount of rainfall. You can measure the amount of rain. It may have only been a few drops more than the previous time you measured it, and that shows how we can have values at any time. We've already talked about recursive and explicit equations. We're going to start with the continuous equation. That is when we could just say the function at whatever x we specify is going to be x plus 1. So whatever value of x, we add 1 on, and that's what will be the output. It's okay for any value of x because, as we see in the graph, it's okay to have a non-whole number, which is still going to go up and hit the graph of this function. Discrete equation example. If we're talking recursive, we could say the function at 1 is 2, and the function for an n is the function at the previous one plus 1. An explicit discrete equation could be saying the function for an n is n plus 1. When we're talking in terms of context or a story, how the change happens is the key. So for a discrete function, the change happens all at once. For a continuous function, the change happens continuously. We are looking at the domain. Now, before we get into that, we need to cover something called set notation. And so that is how we're going to express the domain for the discrete and continuous functions. The domain of a discrete function is the set of n such that, it's the bar, n is a whole number. And then a closed bracket. Or we could say the set of n such that n is a natural number. So in this set notation, we have the set of, And then we have the variable, the bar meaning such that, and then the contents of this part is whatever this is that you can fill in based off of such that something is true. We're saying that the variable in whatever this situation is has to be true. So in the case of the discrete domain, the n used has to be a whole number or a natural number. And so that is why it has to be in the graph individual dots. We have to have the natural or whole numbers, meaning we can't have like the quarter that can show up in a continuous function. The domain for the continuous function, we have the set of x such that x is a real number, is true. Or we could say it's possibly some other subset of real numbers, such as only positive numbers. We can still have more than just whole numbers, but they need to remain positive, something like that.